And here we are. It is finally time for the Stream Deck. So we are here on my desktop because there are a number of things that we need to talk about before we actually get started with this. Also, i.e. the piece of paper to start drawing. So, I know we're starting on the desktop right now, but that's just for the intro. Let's really quick look at what a typical Stream Deck looks like. So, this is the thing we're comparing to. The most important thing to note about this, I'm going to say, is that these buttons have icons on them. They're LCDs, mini LCDs, or I mean, it could be any number of things, but point being is that, I didn't actually check. Point being is that you can put pictures on there. That makes it very easy to customize and, know exactly which one's doing what thing. I looked at doing a full LCD screen, and basically for the price it would cost me to get an LCD screen, let's say about 7-inch LCD screen, which would be what I feel is reasonable for reaching over and hitting for a Stream Deck. In order to get that, it would cost about as much of a Stream Deck as a Stream Deck, so that is why we're not going that route, why we're going with physical buttons. So that is one thing that a purchase option would get you that we don't get in this situation. We're not going to get the easily customizable buttons. The other thing is, and I haven't seen this around, but in theory, since these are just icons on the screen, you could program it for pages, right? So again, that's the way we're going to compensate for that one, for not having multiple pages and being able to like click a button here and switch over to a different set of icons, is we're going to make our model extendable, as in modular, and therefore we're going to be able to stack multiple of these. That's the idea. So those are the major differences between how we're designing ours and how a Stream Deck normally works. So next, let's switch back to the camera and take a quick look at our buttons. So since we're not using LCDs, these are just keyboard buttons, mechanical keyboard buttons. These are the things underneath the keycaps, and one of those things, we'll figure out what we're going to do with the keycaps. Also, how big we're going to make them, because we can make them a bit bigger, One of the things like a space bar, we could have, a space bar, your caps lock, your shift locks. Those aren't multiple buttons underneath it, right? That's just one big keycap on top of one button. So one of those things, those are the options we have for how we're going to design the key caps, but that's further down the line. The other thing to mention about these guys is, well, actually, I did take this apart, so let's just talk about the insides really quick. So on the inside, we have a pair of terminals, just two. You can see them sticking out the bottom, just two terminals. That's fine. All we need to do is detect a current through it. Is no problems. We're not doing anything else with those two terminals. And then we've got our spring here and the little plunger right here. And the plunger just obviously goes onto the spring, and then we just got a cap holding everything together. So very simple. In case you haven't seen one of these, that is how those go together. Very straightforward. And I can't, okay, yeah, there is a front and the back, so let me make sure I'm getting this correct. That side. So let me just put this back together really quick. The reason I took it apart, which I'm getting to, is, oh, I guess this plunger also has a front and a back. Okay. My first time taking one of these apart, so there we go. And that is the front side right there of the acrylic case. So anyway, the point being, I took it apart because I had read on the item description that you could put LEDs on these, and I had no idea where the LED was going. So I took it apart assuming that it went somewhere on the inside, and as usual, my guesses are wrong. So let me get a little bit closer here, attempt to get the camera. Oh, that's right, I have autofocus off because it was messing with it. So regardless, let me turn the autofocus back on then really quick to get you a close-up here. Camera control, focus, auto, apply. Alright, autofocus back on. So, try to get this focused on my hand. See if we can get that. It's funny, I see YouTube videos, of this happening, and I'm always like, you can cut that out in a YouTube video. I don't have that leisure. So you're just going to have to live with me trying to get the camera to focus in the correct position. All right, anyway, it's one of those things. I'm not going to take up too much of your time. Do you see here the little slot at the bottom? That slot is actually where the LCD goes, as it turns out. I mean LED, not LCD. We're not using LCDs. The LED goes. So the LED actually fits into that slot in the bottom and gets wired separately, which is fine. I don't mind it being wired separately. I was just a bit surprised. Also, it is obvious, maybe not obvious to you, but 3mm LEDs, which I do not really have any of, and I'm turning autofocus off now to make sure that it doesn't start getting wonky during stream. I don't have many of them. This is my random box of unsorted crap that came out of random places, and I have a few in here, but I'm probably just going to end up pick up a multi-pack of 3mm for this project. And the reason I'm picking up 3mm is because I mentioned, you have no opportunity to toggle with the Corone rotator face thing that I made. The Stream Deck, Novelty Stream Deck is what this stream is called, and soundboard. One of those things. These do not toggle, so we can't mechanically have the LED on and off for a toggle, for example, mute and camera or whatever. So for any of those things, we don't have that opportunity. Windows Sounds can't toggle them on and off. But what we can do is we can do that in software. And it's one of those things, if you look at your keyboard also doesn't have mechanical toggle switches on it. But you still have caps lock, num lock, scroll lock, etc. So it's just one of those things. We will have toggle bit in on the software side, and to indicate the toggle, since we don't have actual mechanical toggle switches, we'll use the LED. So that is how, that's what we're working with. This is going to be our base. We'll build, obviously, a 3D printed enclosure for it. Again, I do not yet have the capabilities of doing PCBs. That would be a lot easier. Well, not necessarily a lot easier, but it would be a little bit more compact at any rate, and it would eliminate the need to get these fixed in the exact position on the 3D printed part. Again, not too much of a hassle. It doesn't put us back too much, but if these were just plugged into a PCB with a stem right here and then soldered on, it's one of those things. Just one less thing to 3D print. So that is, again, the materials we're working with. So let's talk about what we're actually doing, which, again, is why the paper's here. So plan is very simply array of buttons. Array of buttons, we're just going to multiplex. So that means that for each row, we have a wire, okay? And then each column. So you can see here, we have 6 wires. Or no, actually, derp. That is not how that works, right? Anyway, we're going to multiplex the buttons. If I could edit that part out, I would edit out that part. My brain is just totally derping at the moment, but we will multiplex these buttons so that we do not have as many wires. We do not have 6 wires. Oh, that's 5 wires. Yeah, hold on. Maybe I'm not derping. Maybe it's just a bad example. Let's go 3x3 really quick. Yeah, 3x3 would be 6 wires, and that gets us 9 buttons. Okay, yeah. So I scribbled that out. Obviously, I was not, so I shouldn't say obviously. My plan for today, and I didn't say this at the beginning, but this is just a design stream. We're going to do the electronics in a separate stream, the electronics and the coding in a separate stream, which is why I did not prepare anything, but yeah, that's multiplexing right there. So that's 6 wires controlling 9 buttons. So the plan is to have the buttons multiplexed, and then the way we make it modular is by multiplexing in more buttons, and we'll get to that when we get to electronics section. But needless to say, we'll figure out how many buttons we need on each pad, and I think it will be 9. I think we'll be going with 9, and then we're going to just stack up a whole bunch of pads is my intention. and slide out until we get to the pad we need. The idea here being is that you're going to have one pad that you use like 90% of the time. If you have a second pad at all, if you need more than 9 buttons, those other buttons you're going to need like rarely, if at all. And then if you even need a third set of buttons, at which point we're up to 27 buttons, right? If you need buttons, what is that, 18 through 27? If you need buttons 18 through 27, those are buttons that you're probably never using. You just have them because you feel like you might use them someday. So one of those things. Them being stacked up like this, it's not going to be that big of a deal because it gets rarer and rarer the further you go down. Furthermore, the intention is to stack these in such a way that you don't have to move one at a time. So if you did need to get to the bottom, you can move the top 2 at the same time and get to the bottom. The reason we're stacking up like this is because, frankly, space is a factor. So I would prefer most of the time for it to just be one uniform cube that is only taking up just so much space, and all space is taking up is vertical, which is a lot easier to accommodate than spreading out these keypads in either this direction or this direction, right? So this takes up a lot more real estate that is actually usable than them being stacked vertically like this. So that's the rationale behind this and how we're going to go about designing it. One last thing to note on, as you may have noticed the picture, a lot of times the launch, I keep on calling it a launch pad, the Stream Deck is set at an angle to make it easier to hit. That's not really an issue for me because I'm planning to mount it on my right, probably roundabout desk level. I'll probably recess it a little bit below the edge of the desk because I can actually attach to the edge of my desk over here. That's how I'm thinking of doing it, so it may not be necessary to me, but we will, just in case, we probably will design it so that it can be sat at an angle so that you can hit it like this. Again, the idea is that if you hit it straight down, that's a bit more awkward, which is why it gets put at an angle. And one of those things, your angle varies according to how you want it, obviously. So that is all the design considerations, I think. Is that everything? So I guess the last thing I will mention is this whole entire sliding part. So in theory, the sliding part, if I'm using PET, which I am, yeah, slides relatively well against each other, but I'm thinking just because, let me actually grab one to demonstrate. These are my 623s rather, not 608s, 623s that I use in a lot of projects. And as you can see, they're smaller than the buttons to begin with. So I figured, well, one of those things, if we use rollers, then that should, in theory, make it even easier, and they're not taking up extra space because they're smaller than the things going inside the 3D printed enclosure. Now, granted, we'd need rails, up and down to keep this from just falling off, but, and the point being that adds a little bit, but at the same time, even if I move this down to the bottom half here, you can see that the area above the wheel, basically the clear part right here, is more than enough meat, and the wheel still only bottoms out at the bottom of the switch, and we're going to have wires and stuff below that to begin with. So one of these deals, we can accommodate it. We have the space to accommodate it, so I'm thinking of going ahead and putting 623s on there just to make it slide a little bit easier. And I guess on that note, keeping it from, so if we have it at an angle, right, and it needs to slide, we're going to want it to slide backwards is the only issue, because if it slides forwards, then when you go to hit it, so assume this is the top thing, the top case, and I want to hit the one below it, right? If I slide it forwards, now I'm reaching over that top case, that top enclosure with buttons to hit the buttons below it. That's a bit awkward, which is why you want them to slide back away from you. That way you're not reaching over them to hit the buttons below. So that is the other thing that we got to figure out. And also, because it slides backwards, we kind of need a bit of a locking mechanism to keep it from sliding forwards while you're trying to hit the button, right? This is only really important if you have it at an angle. If you have it flat, then it shouldn't slide forward on you. It only matters if it's at an angle. If it's at an angle, then it's going to want to slide downhill, right? And stop you from hitting the buttons. So that is all the work to prepare us for the design. So let me switch us over and hop on in to Fusion. All right, here you can see, so this is a model I downloaded off of GrabCAD. I checked the sizes, I printed a little test piece, and it matched my switches, like the 3D printed part fit into the switch perfectly. So I know that these dimensions are safe to use for 3D printing. Only changes I made from the GrabCAD model, because the GrabCAD model is just a, I think it's a step file. So it doesn't have any fancy stuff on it. So this clear acrylic up here that I put up here, so you can see through like the actual switch in physical real life, I just changed that appearance. And then I also made it a rigid group to make sure that it, you know, all moves as one. I can't actually drag it on this one because we're still in base, what you call it, base definition mode, whatever that is, no history mode. But here you go. Over here on our actual Stream Deck file, you can see I can slide this all around and they don't separate. So those are two changes I made to the GrabCAD model I downloaded, and we are now off to the races. So first thing to talk about is that these modular sections that we're making, we don't want to use up space for an Arduino in each of them, because only one of, I mean, unless we wanted to. So if we wanted to put an Arduino in each of them, then we could coordinate the Arduinos, or even have, yeah, well, they'd have to coordinate back to a master Arduino that would then send the USB signal back to the computer. It doesn't make sense to have multiple USBs going back to the computer, so we have to coordinate them like that, which is one difficulty, although one of those things technically possible. The other thing is just it costs money, right? So what we want to do is only be working with wires that go back to one Arduino, and that means that we're going to want another case. Is something I neglected to mention, either another case or a master case that is slightly different from the one we're about to design that can house the Arduino. Again, the reason not to design all the cases the same, or the reason to not design all the cases with space for an Arduino is just that that's extra space that we don't need. That's going to be a blank space inside of the piece, inside of the box that we're printing. That is just wasted plastic. So that is why we're going to avoid that. So. One thing I want to really quick do is get these dimensions here, because I forgot what those dimensions are, so I'm just going to hop in here. Dimensions being what kind of a hole I got to cut out here for this to fit. And I'm going to go ahead and grab these guys. Whoops. Actually, you know what? Let's instead of that do intersect, and I guess I'm gonna have to click these individually, huh? That looks to be the bottom case, which is the only thing I worried about. So let's do that, and let's see what that looks like. Turn this off. Yeah, so this is the tab right here. I'm pretty sure I was safe just grabbing this right here to that. I think this might have been the way I did it. It's been a couple weeks now. Again, it was a couple weeks getting in here. So these are 14 by 14s it look like. Yeah, okay, so 14 by 14 is our size that we're looking at to put into the holder that will hold all the switches. So let us go ahead and do that. And how do we want to, I guess I'll do a bottom case and then a top case is how we'll design it. Or maybe it will be a bottom case, a middle case, and a top case. So let's do the middle case then, if we're going to do it that way. And then we'll get the switches put in place, and then we'll design from there. So this middle case is the place where each of the switches will be actually placed in, where they'll be snapped into place. So in theory, I guess I should decide. Let's go with 3, 4. The question is, we've got 14 by 14 as this minimum space we need for each switch, but we want to buffer around them. So let's go for 20, I think. I'm thinking 20 should be more than sufficient as a buffer around the switch itself. 20 minus 14 is 6, which would be 3 millimeters on each side. Yeah, that sounds safe. And actually that ends up with 6 millimeters between buttons, right? Because it's 3 millimeters here and 3 millimeters here. So imagine a switch here and a switch here. That's 3 millimeters here and 3 millimeters here is what we're allotting, which is 6 millimeters, which is way more than enough space. The only question is, one of the things back to keycaps, that gives me space for the keycaps, and the space again would be 20 by 20, and those keycaps would be directly up against each other. So if I cut the keycaps down to 18 by 18, that's probably reasonable. And then we'd have a 4 millimeter space between them, which is probably a little bit overkill. So maybe we do 1919. Okay, so I think that's the plan. I think 1919 is our plan for the keycaps. So let's go ahead and take that down. Keycap square is 19. And actually I should also do the switch spacing. I was saying was 20. Okay, cool. So in that case, this area right here that we're defining can actually be the key switch spacing times, and I think I was going to do 9. That's what I said when we were talking about this. I'm just double thinking really quick whether or not I want it to be more than 9, because so that would only be 3 inches across, right? Which is quite small. Like, we can afford bigger is my thinking right now. So if we can afford bigger, if we can go to like a full 4 inches, that's still not taking much space. We get a bunch more buttons. You know, that goes from 9 to 16 buttons, right? So fact of the matter is that at 16 buttons, that may even be more than I'll ever need to begin with. The real question, yeah, you know what? I think we're going to stick at 9, actually, instead of going up to 14. So here's the thing. 14 only adds 2 more wires, gets us 9 to 14 is 5 more buttons. So 2 more wires get us 5 more buttons. Assuming I just did that math right. Again, math on stream, not a good idea. But we're getting 5 more buttons for 2 more wires, which is cash money. You know, it's still a reasonable size. But the fact of the matter is one of those things, necessary versus unnecessary. And I don't know that I'll ever even need more than 9 buttons on the one hand. And on the second hand, the whole entire point of this is we're doing something interesting. So with the sliding part, you know, otherwise one of those things, it's just a normal stream deck. So we kind of defeat our purpose for existing here if we go up to 14 buttons, because there's absolutely no way we need more than 1 plate. And I'm already pretty confident we may not need more than 1 plate to begin with at 9 buttons. So it just seems like a very bad idea, even though it's cash money profit, you know, going up to 14 buttons, going up to, or, oh, that's where my math is going wrong. It's 4 by 4. That's where I got the 4 from. So that's 16. So 16 to 9 is 7 buttons. So we're getting 7 buttons for 2 more wires. And it is just, yeah. It costs us way too much otherwise to do that. So let us keep it at 3x3 then, in that case. And actually, I don't really even need this because I'm just going to extrude that out. You know what? I'll put this one in here anyway. And we can take this up to the corner because this number has our size in it, which is not keycap spare, switch spacing. So the overall size here already has some buffer around our keycaps, or around our switches anyway. So that's why I can do this in the corner. We'll have meat because we're only going to cut out. Actually, let me go ahead and cut that out right now. Spacing. And let me do this. So in here, I was trying to square this up and then I just derped there a little bit. There we go. Let me go ahead and make that parameter. Keyhole is 14. Keyhole is probably not the best descriptor of it, but keyhole and keyhole. There we go. So this, you can see here, this is what we're going to be cutting out to begin with. This is the hole we're going to be putting here to put the MX switches in. And therefore that already, this 20 already gives us a space on the outside edge of each of the buttons, as well as obviously plenty of space in between the buttons as we array them out. So that was my whole entire point. So spacing times 3 because we have 3 buttons, and spacing times 3. I could be doing equals here. The reason I'm doing 2 separate formulas is in case we ever want to change it. This right here, this key size will never change, but in theory we could change the vertical spacing and the horizontal spacing individually, and we could also change the number of rows and the number of columns here, which actually, just for one of those things, parametric design, I'll go ahead and do that. Keypad rows is 3, and this is non-united. And keypad columns, non-united. All right, I can't up arrow, is 3. There we go. So by keeping these separate, it gives us just some flexibility that we're never actually going to use. Whoops, that was the wrong button. Keypad rows. All right, cool. So this, I forget how thick I made this. I'm going to take a quick measurement off of when I did the test piece. I measured this originally and then compensated, I think, but for right now we're going to call it 1.5. 1.5 obviously is significantly smaller than I normally make things on a 3D printer, at least an FDM 3D printer. I'd probably be more comfortable with the small features like this on a resin printer, but I do not have the means or the space for a 3D derp for a 3D resin printer right now, which is why I do not own one. Otherwise, I totally would own one, frankly, given the opportunity. This is middle case. Because it has a lot of uses, the smaller print resolution and the fact that their fused layer has a lot of uses. I could get a lot of use out of it, rather. For example, I've talked about playing D&D before, right? I would totally do more models. I've printed a few models FDM, but frankly I'm just not thrilled with the quality of them off the FDM printer. The big ones are fine. The bigger models, the monster models, are really not bad, but the smaller models are that should be extent. That's why that's doing that. No, we are not extent is what I meant. Yeah, there we go. The smaller models just plain don't work. I mean, I shouldn't say don't work. I know some people get really good at printing them, but it is not my cup of tea, frankly. Spacing. There we go. And this is what I was trying to change to columns. There's columns. This is rows. This is spacing. And there we go. All right, cool. So that's our middle case. That will hold the switches themselves, and then we'll put a box around this. Again, we only need just so much in each of these cases, because we'll do a master case, or not even a master case, but a base case that will hold the Arduino and anything else that we need. So, for example, it'll probably have JST, I'm thinking, just because my JSTs, I trust the JSTs to stay connected more than the DuPonts. So I'll probably use JSTs for this guy, and we'll have JST connectors in the back of it to connect more modules exterior. Otherwise, as I said, obviously we have the boundary, the meat around the edges here, and this 20 millimeters should be more than enough space on the inside here. So what that means is that let me just take a quick look. I mean, we've got maybe, so let's actually, before I say that, let's grab this guy. And actually, you know what, I'm going to come up here. I had him in here assuming that we just go right at it and bring him in, but it makes more sense to insert him over here. So let's do that. Insert into current design. Okay. And we want modify, align, that guy. Okay, so that's how that's going to be sitting. You can see how the switch itself only overlays by like a millimeter, if that. One of those things I could literally just take the measurement right now with inspect, but I'm not going to. Actually, you know what? The other thing I should do is, rather than put that guy here, because he's going to be in the way every single time I try to import another one, we'll go ahead and get him over to this guy. Let me turn the sketch off. There, and then modify, align. All right, I'm going to have to turn the body off really quick. Try not to double click because that's silly. It's this wall, right? Yeah, okay, that wall is fine. There and there. Now, one of these things, back to Fusion. Fusion, I would love to, at this point, capture position, square, components, click them, select that, and then do exactly what we did. Columns, spacing, rows, spacing. I'd love to do it this way. Yeah, my only concern is that if I do this, oh, it actually didn't do it this time. All right, one of these things where some things in Fusion do not act the way that you expect them to, because they have different functions in different areas. Okay, so for certain objects and for certain functions in Fusion, if I change the visibility on that piece, literally all of the other keycaps would have changed. It would have disappeared as well. That's what I was expecting. That did not happen. So actually, I guess I am going to stick with the square thing right there. I was actually considering sticking with it anyway, just because I don't anticipate modifying this model at all, so it's not a problem to begin with. But I wanted to bring it to your attention, was the whole entire point, that you might run into this situation where you have all your keycaps, you array out your keycaps, and then you go and write something on the top of one keycap, and all of a sudden you see that text written on all the other keycaps as well. That is one issue with Fusion, but that does not appear to be the case for this exact situation, which may be because I inserted the model instead of creating the component inside of this design. That may be the reason. But for right now, not going to think too hard about it. So with that done, the next thing we're going to do is the bottom case, I believe, just because that is easy enough to do. And before we do that, to prep ourselves for doing that, did I not have a construction plane? I did not have a construction plane. What construction plane are you on? Are you just on the XY axis? Hitting refine is going to clear it. I guess that's just on the XY axis. I thought, it's hard to tell. I thought that I did that on the component, but then I deleted the component, right? I deleted the original switch, and therefore I would have expected this to turn yellow saying lost plane, but that did not happen. So we are going to go ahead and continue like nothing is the matter and just create a new plane, because I'm not going to look a gift horse in the mouse in the mouth. I can speak. It's a fine. Bottom of middle case. Draw the sketch, and now I'm just going to throw some standoffs in here to attach to the the bottom case. And now the way we could do this, there's a couple ways we could attach this, right? So back to our good old friends, the bolts. We could run bolts through it and screw it down to the bottom. Let's see what that looks like. So M3s, let's say. And then we want 2mm walls around the M3s. So there's that. So we do have clearance right there. Actually, it's a little questionable on the top there. That looks like it may be clipping the switches. So we have two options in that case. We could always, because again, this is parametric, we could come in here and change this to 21. And you can see everything moved out. Now the reason, whoops, I'm trying to get back to the straight on top view. There we go. The reason these are all the switches are not quite in the correct position is because this top left one is what we've based it off of, and our model is based on the origin. So back to Fusion does not realign things when things change. So we have to come in here and realign it ourselves, and then everything else should line up. So I'll hit that really quick. There's that, and then there is, try to find the face. There we go. So in theory, the first one is lined up and everything else is just square patterned off of that, which means that everything else is now lined up correctly. So going back to the top view and rotating, because you know things look right in certain directions even though it does not matter. So now obviously we have enough space there for the wall around the 3mm, although let me go ahead and hop in here and just make sure that we have 5.5-ish. Okay, yeah. So I can do math, and obviously 3 plus 2 is 5, plus 2 on the other side is 7, which is bigger than 5.5, which means that we would have the space. So one of those things. You can be lazy with math if you want and just have the computer tell you, or you can not waste 30 seconds drawing it out and just say, okay, this is in 7 diameter circle because it's 2 plus 2 plus 3. So clearly that's more than 5.5. I'm just saying. Some of us choose to waste our time doing stuff that is completely unnecessary because we prefer not to think. So at this point, we can bolt this down, this plate down. The other option I was going to say is on the bottom case, we could just have an press fit on these. Let me actually bring this down just so that you can see what it's going to look like. Distance to object. It's hard for me to tell what is the furthest down object on this model. I'm gonna go to, I think I'm gonna go to this face, and then I'm just gonna give ourselves another, let's say 5mm, just to give our wires space to route through. So we're gonna have these standoffs here, right? This standoff could just fit into another ring on the bottom, basically, and press fit into there. Honestly, that may. So the only thing I'm thinking is we need a way to attach the top to the bottom anyway. And if we're going to be attaching the top and the bottom, then we could also attach the edges of this to that. So it's one of these things where we may just be overcomplicating things by adding a bolt going through holding the middle case down. That may just be total overkill, which is what it sounds like to me. So I'm going to go ahead and put that back to 20 millimeters by just rapidly hitting the Control Z button. There we go. So there's that. And I can actually hit Control Y. Actually, no. We don't even need this guy. So let's just delete that guy. Have this guy center lined. Okay, there it goes. And then we can just call this whatever. Because again, at this point, I've talked myself into just having this be a regular standoff and not actually fascinating, not actually fastening the middle case to the base, just having it pressed in, sandwiched in between the top and the bottom. So, since that's the way we're going to be doing it, there's no sense in putting all the effort into everything else. So again, down to the face, and actually I should, just for the sake of sanity, use this guy. This is the original guy over here. So just to make sure nothing goes wrong ever, we're going to do that. And again, I'm going to just add another 5 millimeter, should be fine, standoff for wires to go underneath the buttons. And now we can go ahead and circle pattern that one feature, that guy, and we're centered on the origin, so we can do that, attempt to do that. All right, click Z, there we go. And we want 4 of those. Okie dokies. So there's our standoffs, and now we can start doing the base. New component. Bottom case. Obviously base is short for bottom case and not actually anything else. I will go ahead and actually come back up here, back to keeping my construction planes all in a logical place. This is bottom of the middle case standoffs, and therefore it should go in the middle case. It makes the most sense. There we go. And now we can come back to the bottom case, the base, and draw this out. Now, let's think about this a little bit. So I do have meat around these edges here, right, for the switches, but we were also, our keycaps were 19, right? 19, which is 8.5 on each side. 8.5 minus 20 or minus 10 is 1.5 millimeters. So we have 1.5 millimeters around the edges, but we maybe want to extend this plate out further because, again, now our plan is to sandwich the middle case between the bottom and top cases. So in that case, we might want to come back in here and add some meat around it, but we'll start designing first the bottom case, and then we'll come back to address that. I just want to mention that is something we're going to need to address. So I am going to, I guess, I'll just do it all in one design. I was trying to figure out what order I want to do this in, whether or not I want multiple sketches for putting the little centering rings on the bottom here for these guys, and then doing the overall bottom area. Again, there's a million, as I always say, there's 1.5 million ways to skin a cat, and we're going to just pick one. So there's that. Now we're going to want, I'll go 1.5 because it's not really doing much. All it is just getting us right in place, because again, the middle case is going to be sandwiched, so the middle case isn't actually going to be sliding back and forth against this peg, which means that this doesn't have to be particularly thick because it's not supporting anything. It's just to keep us centered. So that's all it's doing. Otherwise, let's go ahead and extrude this out. We'll extrude everything first, do the base, and then we will come back and I'm going to go relatively thin walls on this guy, because it's not going to be taking very much force. Like these buttons, I'm not going to be standing here hammering on the keys, right, of this Stream Deck, because I'm just going to, it's not what it's for. It's not a keyboard. It's not a keyboard. I'm just reaching over every once in a while to toggle or switch scenes or whatnot. So it doesn't have to be particularly sturdy, point being. So there's our bottom, and then we can toss this guy up here, and we'll go up again. Just like 2 millimeters is fine, because all it's doing is just keeping us centered. As before, circular pattern works just fine. That guy around the origin 4 times, and hit OK. Now, the next part is the part where we do have to consider what we're doing here. And again, I think I will be adding more meat here. So let's see. Yeah, I think I'm going to come back up here and modify the middle case first. Actually, no, I will not. Okay, yeah. Okay. So basically, my thought process here is I like that. Oh, no. Sorry, I keep on talking myself out of this. So I like the idea of having a clamshell-shaped Stream Deck, rather, not Steam Deck. That's a completely different thing. Stream Deck case. I like the clamshell look where it flares out in the middle and then narrows at the top and bottom slightly. That just is appealing to me. But because we're going to be putting the slides or rollers on the sides here, it really behooves us to have a flat edge. So I was going to go ahead and leave this as it is, and then extend this out and loft this wall up to meet the top one. That was my plan. But at this point, because we're going to put the rollers in, I guess I will roll back and just make the middle case bigger, and that will make the bottom bigger in proportion and give us flat walls on the sides afterwards. So let's do that. So toss this guy in here. Actually, rather, nah. Yeah, so this is one thing that we could change. So this right here, this is my overall size for the, basically for the keycaps area, the area where the keycaps will be. I can leave this like this, throw this extra box on there, and then we're good. That works perfectly fine. The other thing to do is to actually add a wall section into this, like a plus 3mm walls for it to clamp onto. But then I have to move these guys, these 2 boxes, out of the corner. These guys are anchored at the corner right now. I gotta delete these and move them in by that wall distance. So those are, again, 2 different ways you can do it. I'm going to opt for the simpler, more straightforward way, which is to just add another box around the other boxes for the extra wall. And this wall, because this is the part being sandwiched, I was going to say I was going to do it 3mm, but again, I don't see any actual reason to make it any. Actually, rather than do this 2mm here, it makes more sense to do this plus 2 times 2. And the reason it makes more sense to do this is because it makes my life easier. Instead of having to define 2mm offset, 2mm offset around each of the corners, now I just put 2 formulas in here and we're off to the races. There we go. And make that transparent construction line, hit OK. And let us see. So obviously the body, something went wrong with the body here. It has decided that it's missing the profile. I was hoping because I changed that construction to that construction line and the other one was solid, it would just pick it up. So for example, let me open up a new, here. A lot of times if you do something like this, okay, and I've got this right here, if I extrude this out 2 millimeters and then come back and do this, nothing breaks because it recognizes that it's in there. I was hoping we'd be able to do the opposite. So, you know, basically start out with this, which you see still works. I mean, it still works because it knows it's there, even though I deleted the outside one. That profile is still selected. That's internal profile is still selected when I do the 2 selections for the extrusion, and that's why it still works. I was hoping, however, that it would look at this internal profile and go, okay, that internal profile bled out to the outside. It just extended outwards, but obviously that did not work, as you can see there. So that was my rationale for trying that. Did not work. So we're just going to have to come back in here and fix these guys. You actually, I don't know why you are not working because you make sense. There's nothing wrong with you. Let's flip this around back and forth and see if it fixes itself. No. Distance. No. We've got our one profile. This is interesting. I actually don't know why this one's not working. All. Join. Cut. So it's the same body, so I don't know why it wouldn't pick up the same body. Let me do this. I'm going to roll the, back. Oh, that is why. There we go. So it deselected, back to it has the multiple selections in there. It deselected the whole. That's why that one wasn't working. That makes sense. And then this is just missing the edges now on this guy. The way I could have avoided this is by doing this, by using the origin. As you can see, that flip-flops me here, but I forget, is there a flip-flop button down here? I don't think there is. No, there isn't. So, for example, if I want to use the origins, I'm just going to have to annotate this correctly by changing that one to minus. Because the reason why that is, obviously, is because I'm starting from the top left. So this is y minus in this direction compared to the origin. That is why that does that. And again, same thing with this. I'll switch it to the origin just so that in the future it does not break. There we go. And we just then have to swap this around because the origin, whoops, not that one though. That one. I'm actually, so I guess that the reason it flip-flopped the X and Y on the X and Y direction here compared to the origin is, I'm guessing it's using the internal origin of this guy is how that's working to reference which way to lay it out. That's my guess on why that did that. So back to where we were at. Come back down here to the end. And again, we're going to bring this guy straight up. We have a 2 millimeter edge to go around. Actually, maybe I wanted 4 millimeter. I probably wanted 4 millimeter. All right. And the reason I wanted 4 millimeter is because it has to be sandwiched, but I also need a wall on the outside for the top and the bottom to connect to. So that actually does bring up a good point of how am I clipping this together? Because if I'm clipping it, I guess it doesn't necessarily matter. Okay. So if I put clips, sorry for that loud noise. That was me banging my coffee cup against the frame of my keyboard shelf, whatever you call this thing, this slider thing that slides out for the keyboard. So if I throw clips in the front and back here, that would leave the sides open, which is what we may do. The sides being where we're putting the rollers. So that makes sense. So I may not have to change the size. And it this 2mm wall right here that I add in, frankly, it's probably okay. It's probably not going to make anybody cry if that's visible, if that seam is visible on the edge. So let's go with that. I think that's what we're going to go with at this point. And if we have to come back and change the design, we will. So all that means then, in that case, is that I'm going to come back down here and draw a wall in, center it up, and make sure that it is 2mm and centered on that, and 2mm in that direction. There we go. And then we can go ahead and, well, don't extrude here. We got to hit finish sketch first, otherwise we're going to screw everything up. Oh, actually, that just, wait. Wait. Why are you looking silly right now? Why is my blue bigger than my brown right now, or my gray right now? That doesn't make any sense. What sketches do I have open? I just have the one sketch open? Oh, I see what happened. Okay. Back to, I gotta come down here to this guy and reselect the edges. Okay. Almost okay. Somehow gotta click all that. Now okay? I guess now okay. And that guy too, huh? Yep, that guy too. This guy should be fine. I don't know what he's crying about. Alright. Back to your regular scheduled program. That guy. Distance to that guy. There we go. Join. And there's the bottom half of our case. Now we just got to figure out, like I said, well, like I said, on the one hand, we got to figure out how these are all joining together. On the other hand, we also have to figure out how we're doing our slides yet, because we haven't talked about that yet. But in the meantime, I will just put the top case on. Actually, so here's the deal. The keycaps are going to hide most everything. So rather than having a top case to begin with, yeah, okay. You know what? I was thinking I was going to put a top case on here, but that doesn't actually make sense. The keycaps are going to cover everything. So let's roll on back here. Change parameters. This is going to go back to 21. Okay. And we're going to change this back to a screw down. And the reason we're doing that is because we're going to only have two cases. And I guess I did not think through this well enough. Otherwise, we could have saved ourselves a little bit of time here, because now I'm going to go back and redo all that stuff that we decided we didn't need. So this is now going to be top case. Top case. I'm going to come into the top case, grab my circles again, and this is going back to a 3mm and M3 bolt with a 2mm ring around it. 2mm. Finish. And then you are actually going to extrude like this. Okay. So you're going to extrude like that. We do not need the ring on the bottom anymore. Where's the bottom case? Because the bottom case instead is going to be a cut operation, and we are going to actually, let me delete it right now. We'll delete both of these for the moment, and I'll put them back in just a second. Instead, I want to come in here to the sketch and fix this sketch. So let me turn these guys off so that I have an easier time of seeing what I'm looking at. All of these guys, whoops. Okay, good. I was going to say that wasn't supposed to happen, so all of these guys in the middle here should be construction lines with the exception of these guys. One of these guys, that orange one, should not be here. There we go. And did I end up with holes? I did end up with holes, so I can just let's see, where is my top left one? That's not my top left. That's my top left? Okay. I want to make sure I was looking at the correct reference point to keep everything similar. So I'm going to turn that back to that, and and then we'll toss our captured nut down here. 5.45. 5.45. And we're going to draw our, actually, this will be our reference point right here, and then, as I normally do, let's see, which line is that? That is, I can delete that guy, honestly. We can delete that guy and that guy. Let's turn this body off now because I'm done taking stuff from that, and then we can draw our 2 millimeters right there. Or I guess 1.5, 1.5. And actually, you do not look centered between those two holes, which is weird. Why are you not centered between those two holes? Let me toss this there. Alright, we are going to, before we extrude that, come back up to the top case and figure out why that sketch is not centered. And that would be the reason why it is no longer connected. There we go, easy fix. So now we can go ahead and extrude that guy. I gotta come into the bottom case though. So we will take that and we will go up the 2 millimeters that we were talking about before. Should be from the top of it though. Did I somehow get flipped around here? I think I did. So let me come here. I wanted this to go down. I don't know if that's a mistake I had sitting around from the beginning and I just didn't notice. I'm guessing that's the case. Okay. How do I want to do this? Yeah, I guess I'll do it this way. So this is one of those things that I've mentioned before. I mentioned on the other stream. The one where I broke down the novelty stream deck is sometimes they do this like this. Actually, yeah. From object there. -2. In theory, this should be exactly... Whoops. That was supposed to be -2. In theory, the top of this cut should be exactly on this plane. I'm just doing that just to be sure. But sometimes I do it this way. I'm trying to get to the profiles. There we go. To include the hole. And as you can see, I brought this up and now I'm going to round this off instead of countersinking it completely in the bottom of the case. That's the point I'm getting to right now. And what this does, it allows me to keep the bottom of the case at the 2 millimeters without making it any thicker and still having the recess for the captured nut. Which is why I do it this way sometimes. Now we can go back to the circular pattern on these guys. This is now a much more complex series of selections, but it should still work exactly the same. And there is those two guys. Those guys line up as expected. Now let me just double check. Top case. Okay, yep. I was pretty sure that was how it was working, but we do need to extrude out the hole in the top. Obviously, because before this did not have the hole in the top. Before it was just, there we go. Before we just had the pegs, so we didn't extrude out the hole. Distance all, symmetric, just to make sure everything gets cut. What's the matter? Oh. Yeah, alright, fine. One-sided, and we'll flip it. It's a little annoying that it complains about that. I mean, symmetric all should just mean everything. It shouldn't matter whether or not it's completed tool body or not, in my personal opinion, but I guess I can't really gripe it for bringing that error, just because there's probably situations in which you really... where the error might come in. So the code that detects that error, that detects that there's no tool bodies, you probably want that everywhere you can, just because the risk of missing that error is worse than having to just readjust my selection so that it was only symmetric, only extruded all in one direction. There we go. So that is my explanation for that one. All right, and this is where we're at now. So we have the switches coming out the top here. These are going to be covered up by keycaps. So I talked earlier about changing the size of the keycaps. We technically could do that, but I don't really know. I can't think of a good reason to. I guess I can. Anyway, the only point being is that I'm not going to do that now, though. I'm not going to build that in now. And one of the things with keycaps that are extra large is that they have a, I'm going to call them an alignment rod, basically something to keep them from canting back and forth, because obviously the keycaps are going to sit right on this cross right here, right? So if the keycap is extra long and you push on it, so let's say the keycap goes like this. If I push on it on this edge over here, then it actually wants to twist off of that plus sign. It's going to want to cant to the side where I pressed it. So they have little metal rods on the inside to make sure that if you press it on one side or another, it all just stays in line. Again, that's something else we'd have to add in, and I'm not going to bother with that at the moment, but it is something to keep in mind if we do want to add that in later. And that again is probably going to would probably end up being its own case, a case with larger buttons, only because we only have just enough room built into this design for 20mm keycaps. I guess actually, I said that, but technically speaking, we could leave this hole open, let's say, and then work it like that. So I guess it's possible to do in this design. Just leave a key out, and then again have a little piece in here to make sure that the button presses uniformly, even if you're pushing on this side where there's an empty hole. So that is that. I'm gonna go ahead and color this in really quick. Oh, wait a second. That's not right. That ain't right. These guys were supposed to go the other direction. I got myself turned around because I had the upper body off. So distance from object there, and this is now going to be a -2. That is going to be distance from object. I am in the second one, right? Where's my... All right, let's back up. Oh no, I changed the wrong one. All right, let's turn the top body off really quick and roll back. Okay, there we go. This is the one I need to change. Object, that one, and -2. There we go. Obviously, this will change our standoffs a little bit here. And honestly, the... let's see. This needs to now go from the top side to that side, and that -2 will be a +2. Or will be a +2. Let's see. That there. All right, there we go. That's going the correct direction, which means that that is still a -2. 0. Where does 0 put me? What's our issue, brosifs? What's our issue? There we go. I must have had the wrong thing selected. So this, like I said, is a -2, right? Yep, there we go. And actually, this should just be distance to here, is all it really should be, rather than the 2. Now, because this is on the inside, there's no real reason why I need this fillet, because it's going to be running directly into, directly into the standoffs right here. So, as you can see, since that's running into the standoff right there, there's no real reason to fillet it, because it's not like visual. I do the fillet for a visual effect, point being. And now let's go ahead and fix this next part. The next part we're fixing here is this this guy right here. I'm gonna change. Please can I change it? Alright, there we go. And I'm gonna do this +2. Fine, just 2. Alright, +2 is the same thing as 2, but if you're going to be a pain about it. And then I'm going to modify these standoffs to be 2 millimeters shorter. So that's going to be 3 instead, to compensate for the fact that we're coming back up the top. So now I shortened up the standoffs so that they're just touching these 2 millimeters that we brought up from the bottom instead of overlapping. And let me go ahead and toss in section analysis in just so that we can see that. Section analysis. There we go. So these, as you can see, are these guys were no longer supposed to be. All right, what did I do here? So this guy, right, is down there. That makes sense. This guy, oh, this guy, no, his profile plane. Oh, he got flipped around again. That's there, that's there. This guy. That guy. Okay, now that's from the top. Okay, Fusion, you drive me bananas. Turn this plane off so I can actually select that. And this should be, no, that is supposed to be -2. So what plane am I selecting? I literally, that face right there, right? Why is it not selecting the face I want? All right, there's sectional analysis off, so I know that I'm not selecting something that I'm not supposed to select. There's the top off. Okay, yeah, that's exactly how I want it. This is from object. You're supposed to be the top here. My 2 millimeter offset is now like this. Okay. Things are funny sometimes. Things are funny. All right. Now everything should be kosher. All right, now everything is kosher. Good bunch of men. That took way more effort than it was supposed to. All right. Regardless, though, we are now on to phase 3. So we have the middle, or now top, connected to the bottom, which shouldn't have taken as long as it did, but you know what? Mistakes were made. And that's okay because we overcame the mistakes. And now we can get on to the sliding part. So this is, let's just make sure we have the front reference correct. So here's our front reference. We want the slides to go on the side. And what I was thinking about this is, I was thinking, and let me just actually, so it's symmetric all the way around, so I should be able to take any section analysis. And actually, yeah. So my thought was to have a slot in the side here, okay? And a ridge in the front side to stop the wheel from rolling out the front side, right? So it can't roll off the front. And then putting a screw just to act as a pin through the back side here. And I was just looking right here just to make sure we have space back here. That pin being there so that the rollers do not roll off of the next lower row. Actually, I just realized We may want to do this in two parts. So I can't have rollers and slots on the same spot, which makes sense. Yeah, okay. We should be fine. This shouldn't be that big of a deal. So this bottom case now is going to get modified. Actually, we can do it. Yeah, we can do it in another component. We can do it in another component. I'm just thinking through the ramifications really quick. So if we add another component completely down here to attach the rollers to, that will get printed a lot easier than if we try to print this with the rollers down here on the bottom. These rollers overlap the top half right here on the next one above it. So if we print it in two pieces, that prints easier. And it allows us to remove the rollers, not print the rollers for the bottom one, which attaches to the base that has the Arduino on it inside of it. Which means that, which we don't need them for. We don't need the rollers on the bottom one that is attached to Arduino. So we're not printing any extra, is what it means. Yeah, okay, so that's everything we got to consider. So let's get that implemented. I'll start with the this bottom case right here. I'll start here, adding in the slots for the rollers to go into. So let's take outside of front. There we go. So outside of left side is what this construction plane is. Of left side. There we go. And let's draw that in. Again, I'm trying to keep this pretty simple here. One thing that I did not consider is I said that the 623s are smaller than the switches. They're smaller than the bottom half of the switches even, but I did not actually, I forget what the outside diameter is. I think it's, okay, it is 10 millimeters for the outside diameter. So let's draw that in here really quick. So there's our 10 millimeters. And if we have that centered on here, I knew it was going to fit, but I wasn't sure how much meat we'd have on either side of it for the slots. And it looks like we have 1.5. Now, the trick here is that I can extend the top plate out a bit to act as the rail. So this is 2 millimeters right here, right? No, this is 1.5. Okay. Okay, so yeah. So, couple things here. One, we added the extra 2 millimeter wall around here, right? How do I want to do this? Actually, here's another idea. How badly can this screw us up? The other idea is to actually leave the top open here. So just do, let me change this back to solid. And instead of doing this centered, I'm going to do 3 millimeters down here. What if we did this? Basically, actually, this, how do I have this connected right here? Like that? Okay. So imagine this with me. Imagine we do something like this and leave the top open. We can do this. We can do a ridge on the back side. Drop the roller straight down onto it. And then just say, well, I mean, what do you mean it's going to somehow fall off? It's not going to fall off. Is that an idea? Nah, that's not really an idea. Okay. It's not really an idea. And the only reason being that we got to slide this backwards. Which means that we can't do it this way to begin with. So. Let us reconsider. Okay. I think at this point, my easiest thing to do right now is to default to the triangle pattern and go with that. So I've talked about this before. when I was telling you about the shelving I plan on putting in my desk, which I still haven't gotten around to, because if we take those 623s rather, not 603s, 623s, they're 10 millimeters a piece, right? 10, 10, 10, and 10, and give them a rail, which is, let's say, 3 millimeters as a reference point. Take these guys up here and tangent them to this guy. And then we can tangent this guy to that guy. Tangent. Okay, they won't fit like that in that case. Okay, that's what I was checking, and it looks like it will not fit, so we'd have to make the case bigger. So basically, this rail right here is what's built onto the bottom, that extra component that we're doing here, and it slides on these three, these three bearings right here. The problem is, as you can see, that these bearings, and it looks like I just locked that guy too. Okay, let's see here. Something is locked in place here, so I can't move it down, but... oh, it's this guy right here. There we go. So basically, I would have to, and this is a 3 millimeter right here, 3 millimeter hole, and 2 millimeters of meat right here. Yeah, 2 millimeters of meat. So I'm just getting the size that we'd have to make this bottom case in order to accommodate this setup is what I'm mapping out right here. So in theory, imagine the case being this much larger-ish. Technically speaking, I know still need to figure out this bottom guy. The rail goes on here, and the rail does not pivot because it has 3 points of contact with these rollers. So even as we slide the rail out this way, even as the rail slides out this way, there we go. So long as it is still in contact with this front roller, it can't actually pivot up, right, and fall off. So this is a way we can design this with these 3 rollers at the back here. However, I do need to make this case bigger. Alternatives is just to have it sliding on plastic, which we talked about before. So at this point, because we got to make this that much bigger, and I was trying to keep this relatively low profile, because even though we have plenty of vertical space, as I said before, it's still it's the same idea behind not including the Arduino space in each of these cases, is that if you don't need to print the extra stuff, then we just plain don't, right? So that being the case, let us abandon this idea of the bearings. I liked it, but it's one of those things that's going to cost us too much at this point in design to implement. You know, we just got to add way too much that is unnecessary, and let's go back to just a rail. So I'm going to Control Z a whole bunch to get us there. And let us go ahead and cut that in. And by cut it in, I mean extrude it out. And actually, back to, okay, so the one thing I started to say is we could extend this edge out to help reinforce the rail. I don't know that's necessary at this point, only because our rail is going to have plenty of meat right here, and we're only going to make it just so thick. Like, I can make it 5 millimeters thick, center it on this guy, and it's still going to have enough enough meat on either side to keep it stiff. Yeah, 4 millimeters on either side. So I think this is where we're going to be at. Again, I do, however, want to move you back, though. So I think that's the correct one. Let's find out. Oh, this guy is also going to stop me. So we will go ahead and do this instead. That is centered there. That is centered there. Make sure this is perpendicular to that. And then we can go ahead and do, or actually, yeah, that's correct. It's this guy that I wanted. Just 3 millimeters out front here. And we should be good. So the only issue that arises doing it this way, putting this slot in here, well, there's 2 issues that arise putting this slot in here. Let me just extrude it first, and then I will elucidate. I guess 3 millimeters is fine. It doesn't have to hold, it's not holding much weight. First off is that this is an overhang right here, and we don't want to relieve this overhang. Let me just relieve this overhang really quick, for example. We don't want to, okay, never mind. It's not going to let me exemplify. There we go. We don't want to do something like this. Again, just going corner to corner here, though. So getting this to there. We don't want to do this because obviously the rail just slips up and out if it has any flex at all. If it has any flex at all, it slips in and right out the top there. If it didn't have flex, that would be a different issue. But it unfortunately does. So it would end up popping out of this, and what that means is that we're going to have to include supports inside of this overhang. The reason why we would need to include supports in this overhang is because our only other option is to print it standing up on edge like this. If we printed it standing up on edge like this, I meant to go to the other edge. There we go. Now we don't need supports in here. However, we do need supports all the way across here. So that is obviously a lot more support material across here than it is over here, printing it on the side like this. So printing it on the side like this is the only supports we need, obviously mirrored across the other side. And unfortunately, that's what we're at because our alternatives are inferior. They create more problems than they solve. So there is that. There are slides now that we're stuck with, unfortunately, because we do not have any other options. The next thing I want to do, and back to, let's see. So when we slide this back, we're still going to be covering up, if you imagine one above this, we're actually going to still be covering up the other buttons the way we have this right now. We need it fully extended back. The way we could do that is we could do something like your slide rails. So the slide rails that you have in your kitchen drawers and whatnot, they have 2 sets of slides. Each of them move half distance, which means that you can extend them out past the edge, right? In theory. And actually, this depends on what kind of slide you have. You have full-length slides and you have like 3/4 or half slides, right? The full-length slides will allow you to extend it out. And again, that's 2 sets of rails. So that is something we got to decide whether or not we need in order to accommodate this design. And I'm thinking actually we may as well. So it's going to introduce another component in here. But our alternative to that is adding dead space in the back here for the overhang. And if we add dead space in the back here for the overhang, then it's kind of like, what are we doing with our lives, right? We're just printing extra empty box space, you know, just because we're going to be covering it 3/4 of the way up with the one above it. So in that case, we are going to change this design once again. Again, every decision has ramifications. I'm going to delete this out and again put this at, or instead rather, put this at 3 millimeters to define it that way. And the reason I'm doing that is because I want as much space as I can get with whatever I've got. So actually, I don't need to put that in to measure this. Actually, I don't even need to do that. So we got 7 millimeters for the part that we're going to put in here. The part that we're going to put in here, then I guess it's going to have to be a 2.5 because I don't want to go 2. We can't get 3. If we had 3, that would be 7 minus 3 is 4, divided by 2 is 2. 2's not much better than 5, right? It's not much better than 2.5. Alright, I guess that's where we're at. So, again, we're going to need a connecting rail at this point. This became more difficult than I was anticipating. Alright, let's draw this in here. One of those things, as I always say, the design decisions have consequences, and we had other ways of doing this, and I opted not to do them that way, so this is where we're at. So this is going to be a diameter 3 millimeter. This is an M3 hole right here. Wow, that is okay. That's radius 3. I don't want radius 3. That is why I was going to say that does not look right. Okay, there we go. There we go. And I guess I will just make this. Actually, I'll do this. It doesn't necessarily matter because this is just the hole we're doing right now. So there's that. And there, yeah, this guy can just go. And no, I do want to leave this guy out a bit. So this is going to be that divided by 2 plus 2, let's say. And now we will go ahead and extrude that in. And this will be a slot for a screw to go through to connect the pieces. That is the idea behind this. So there's that. And we will go ahead and make sure to also mirror that guy. And then we can go ahead and create the slide. New component, slide. And let's see, where do I want to design this from? I guess I'll just use that outside left-hand side for this. I'm going to project this guy out. And I'm just going to make that tangent. And let's see, how do I want to call this? I think I want to call this 3 millimeters. Or actually, what I should do this is 3 divided by 2 plus 2 is how I should do it. And I want you tangent on the bottom side as well to keep you centered. Try that again. There we go. So now that's centered because that's tangent between 2 lines. And it's a circle, so it's a regular shape. I'll make these guys construction lines for ease of extrusion, and then we will go ahead and attempt to extrude that out. There we go. Distance to object, that edge, and new body is correct. So this is my connecting slide. Let's see. The idea here is that the top slide connects to this guy, and then this guy translate like this. How do I have 3 components? I only want this guy. So this guy is going to do all this travel right here, which is going to allow our top slide to travel further back here. The fact of the matter is that it doesn't need to be this long because we only need to clear just so much. I'm trying to think of the math, though. Right. So let me leave this right here for now and go back to another component and draw in the actual sliding mechanism here. So this is going to be slide attachment. I'm going to change this to slide intermediary, or intermediary slide, I guess. Intermediary slide. Okay. Slide attachment. Sorry, just starting a little bit. Let's grab the top case. It's going to have to clear this plus a little bit. So I think I am going to put this inside of this component just because it's offset. So this offset right here, this bottom case mill standoffs, is actually incorrect at this point because I offset it by 2. And this plane really should be moved down here. However, that breaks a whole bunch of stuff, which is why I did not do that. Again, just keeping things organized. So let us give ourselves, let's say 3 millimeters total. So it's going to be like a 2 millimeter wall on the keycap and then an extra millimeter just for breather room is what I'm thinking, how I'm thinking about this. So I'm going to say 3, 2 plus 1. And we'll do that. And I do want to make this a full plate. Is what I'm doing right here. And the reason I'm doing that is because I don't want it. So technically speaking, it could, in theory, I mean, it's a little difficult. It's a little difficult to do otherwise. So I'm not going to actually address that right now. It's just easier if this is its own plate. So let us go ahead and extrude that out. 2 millimeters. And extrude this. Sketch. Turn those guys off and out of my way. All of this. From object. 2 millimeters. And now I've got some captured nuts in the bottom here, is what just happened there. And in this case, instead of the bottom case using its captured nuts to attach to the top case, we'll actually just run an extra long bolt all the way through all 3 of them and use the captured nuts on this roller plate is the idea here. That does mean, however, that I do have to throw these M3 bolts in because that did not get transferred over because we only took A. And I just realized all these are different orientations, which only matters if you have OCD. There's that, there's that, there's that, and there's that. Since it only projected the bottom side, the bottom face obviously does not show the hole because the hole it has in it is the hex hole, which is why we got to add that back in. The hole for the bolt. Equals, 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 and equals, and equals. There we go. So I will come in here and deselect those holes. And there we go. So there's that, and now I just need to attach to the intermediary slide, which is a little bit of an issue, but we'll figure it out. And actually, this is going to need to be at least 2 millimeters thicker on the outside. So let me go ahead and do that. I don't know, it's just plain easier to use squares, I think. Actually, no, it's not plain easier to use squares. And turn the construction line off. So here is that. Just going to have to make him perpendicular and 2 millimeters. Boom, boom. Boom and boom. Whoops, that did not work, obviously. There is that. Okay, and we just need to update. Oh, now see, that worked that time, right? So when I did the other one, it didn't work, but this time it picked up on the extra area around. Fusion is silly sometimes, I'll tell you. I want to add some color in here. I should have added some color to the bottom half too. I just forgot. to help distinguish stuff. So let me come back up here and add that color so I can see everything at the same time. Green, green, plastic, matte, and what was this red here? No, this is blue. So we'll grab some red. Plastic matte, plastic matte. There we go. All right. Now we just need to, as I was saying, drop the slide attachment down. And this is a good reason to change this back to construction lines now that we have extruded. So that we can now just do this. And we'll do distance to sided to object on the one side. And actually, let me check what this side is first. Which side are you going? You're going up first. All right. Distance to object. Again, orientation sometimes is weird in Fusion, which is why I had to check. So for all I knew, that was going to go down. And you should be to the bottom of the intermediary slide. It technically can go further. I just don't see the need to do so. Actually, we can keep you on. I need to turn the bottom case off, though. There we go. So that's now to the bottom of the intermediary slide. And then we can come in here. Actually, let me put this all together first. We'll slow down a little bit. And we'll see how this is sliding. Because again, it's how it slides is a little bit... again, this intermediary slide doesn't necessarily need to be this long is the issue. So let me turn everything back on just so that we can look at it. Because again, I don't feel like doing the math in my head and thinking about it that way. So I'm just going to look at it and then go from there. So let us grab you, translate you out, and you would be, what is it? It is 64, is it? No, 64 is not right. I guess that's 66, 68, 67 doesn't make sense, but it looks like it's 67, so that's what I'm going to say. So the idea here is that this guy needs to completely clear these buttons, right? That's what we needed to achieve, because the keycap, again, is going to go right up to this edge, basically. And then this guy right here needs to make up for the fact that this guy's hanging all the way out here. So this guy should move half the distance. So if that was 67, this is going to be 33 and a half, right? That obviously did not move. Let's try that again. Select component, intermediary slide, 33 and a half. There we go. So that should be moving at least halfway. That way it's halfway supporting the bottom half and halfway supporting the top half. It was longer. If we were able to make this slide longer, it could support all the way to the front and back of each piece. However, we can't. And the reason we can't is that it would be sticking out the back by the full length. That's why. Derp. I don't know why I paused there. I mean, it was pretty obvious, but I was like, wait, is there a reason I'm missing here? No. It's if we made this twice as long, it would be sticking twice as long out the back side. Obviously. So that's about as long as we can make it in order to have it all the way in there. All the way concealed, basically, at all times. I guess, okay, I guess the reason it's 37, which is a little bit of a weird number, is because no, actually I take it back. I take it back. All right, don't listen to me. This slot, however, the inside slot right here, this guy that I'm selecting right here, should go all the way out the back, it looks like, because we need the bolt to be able to travel all the way out the back. That will be attached to the wall of this guy. So that's the first change we're going to have to make. And then this overall slot size, though, is not going to change because, again, it has to house this whole entire thing, and this is as long as it's going to be. So the next thing is the placement of the bolt here. Now, the placement of the bolt here should be against this back wall, and that is it, because we're going to have another bolt right here, which means that we're going to actually... yeah, okay, so if we have another bolt right here, we're going to have a bolt head sticking out on this side, right? In that case, the bolt head sticking on this side is going to need a slot to travel through on the inside wall here. So we need to accommodate that too, which means that we need more than this 2mm wall thickness because the bolt head is about 2mm of clearance. So we need to go actually up to like 4. So let's start with that because that's an easy fix. So this is now 4. There we go. We can put the hole in here. Now again, I prefer to do this mathematically, but frankly, I don't feel like doing the math right now, as I keep on saying, which means that I'm going to go ahead and just capture a position and project some stuff out and call it good. So let's see. We're gonna wanna countersink. Now, which way do we want the bolt to go? I think we want the bolt to go on the inside. And if we want the bolt to go on the inside, or the bolt head to be on the outside, the bolt stem to be on the inside is what I meant to say. So that means that we should probably, we don't necessarily need to capture the bolt on this guy. I mean, we kind of do just to make sure it doesn't go anywhere. It's just a bit difficult because it's only 2mm, right? Is all we gave ourselves. So we only have it partially captured, which may be alright. That may be alright. So let's just get moving and see what happens, I guess. So. Construction outside of left wall, or left, I guess, slide attachment. And which plane were you? You were the top plane? I think you were the top plane. Turn you on. Okay, there you are. I see you now. Back there, yeah. So this is the bottom of inside. Slide attachment. There we go. So grab that guy, and again, I'm just going to project this out because I am being lazy with my math right now. So there's my projection. Here's this, and that is going to be tangent to that. I don't think that actually ended up tangent. No, it didn't. So let's make that tangent to that. And this is 5.45. Well, we'll call it 5.5 just to be safe. This is the bolt head right here. Actually, I don't, for the sake of being silly, I'm going to do that, -2, and then grab that and extrude all. Or, I guess not extrude all. I guess just go to inside. There we go. And make sure I'm only cutting the one body. Sure. Okay, looks good. And then we can mirror that. Create, mirror, features, cross the center line. One of those things, I'm using the origin right now. Technically, I shouldn't be using the origin, but I won't complain to myself. Alright, so that's the update we needed for that guy. We do need another bolt in here, though. So, I'm just thinking. Boo, 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 boo. Yeah, alright. So let's come back in here. Toss another guy in here. And another guy in here. And these guys, that's going to be tangent there and there to be centered. That guy is going to be equal to that guy. And we are going to be at least 2mm away from this wall. 2mm. That should not have been a construction line right there. I'm going to project this wall out to use it as a reference to tangent that 2mm radius on, or 2mm offset from. And then we can just add those onto the stuff we want to cut. I probably should change these guys to construction lines to make my life easier, but I'm not going to worry about it at the moment. So there's that. So this gives me my 2 points so that the top attachment point does not pivot on the angle here. And let us see. Okay, I think we should be fine. So the only thing I was thinking about is what keeps this guy in here, keeps the inner slide, the intermediary slide, from sliding out, and I think that's relatively easy to do. So what I'm going to do is I'm going to come on the inside here. So let me grab my construction planes. I don't have any right now. That's good. And by good, I mean that's fine. It's acceptable. I do not have a problem with it. Inside of intermediary slide, I'm going to go ahead and put a little tab on the front here is my plan. And we'll just have a... Okay, that was not the plan. I thought I had projection. Stop. Hammer time. There we go. And the problem here is probably just that I have all this stuff up here, and therefore Fusion is selecting stuff I don't want it to be. So we will throw that there and make that tangent to that and extrude that guy out. Actually, I take that back. This guy should not actually be here. Let's just delete him and try again. And by delete him, I mean hit Control Z. So this guy is going to need to fit inside of the slot is my issue, what I'm coming to. So there's a couple things actually. We can make the slot bigger on the inside. That's one option. I don't think it's necessary at the moment, so I'm just going to line it up like this. If we need to, we can, but I think we're probably fine here. So that's lined up with this slot, and then we can go ahead and collinear and tangent to this circle and extrude that guy out. Bodies, extrude, and I'm going to extrude it to the inside of the bottom case, plus a little bit. Distance to object inside, plus let's say 3. So there's that. And now on the inside case, on the bottom case, I will go ahead and let's see. Actually, I will use this plane right here, the bottom of the middle case, because I'm going to just bring it straight up from the ground. So we'll project that guy out. Again, there's math that should have been done here and is not being done, but I will forgive myself for not doing the math. And actually, I did want to project the bottom out. I stopped myself, and then now I'm realizing that that is actually what I wanted. Let's turn the bodies off so that we can have a better idea of what we're looking at. This is going to go, oops, not there actually. That was a bit silly. That's going to go there. And this is just my stop, and it can be, you know, whatever. I'll just make it 3. And this just stops the intermediary slide from continuing to slide out the back. And there's no reason why it can't be all the way up to the top. I don't think. It's a little bit extra plastic, but it will connect on this layer, giving me a much firmer, making it a lot stiffer, making it less likely to break, right? So that's why I'm going ahead and doing this. Now, the one issue we may run into here, which I see coming, is these bolts right here. So these bolts are going to come all the way to the front here, and they're going to clip this guy, which is a problem. So what that means is we actually want to change how we're doing this. That's fine. We can deal with this. Not that big of a deal. So this guy instead, the intermediary slide, is going to be designed slightly differently. We can keep him like that. I will, however, come to the front and put a T on him is what... T's not going to work. We're not going to be able to get that inside. Actually, we can... We can't. No, we can't. Okay. How are we going to do this? We could make it in 2 pieces as an option. Actually, I just realized we have a bigger issue on our hands. So the problem was these bolts coming forward, right? Those bolts are going to come all the way forward to the front here. So we can actually avoid this problem altogether by moving this second bolt further back. We won't be able to avoid this issue right here, but we can avoid the problem with this coming all the way to the front by moving it further back. And then we will come back and solve this issue. So... the reason this is a problem if this comes all the way to the front is that it actually can't get to the front because there's not enough meat because we offset this. I think, actually, I don't know that for 100% sure. Let's go ahead and slide him forward really quick. Modify align that to that. And, okay, so the bolt goes through, but we're going to have a nut on the back end of the bolt, right? And the nut, which is this round circle right here, effectively, it's about the same size as the bolt head, is obviously going to overlap. Actually, it's pretty close. It might actually clear. You can see this is the, you might be able to see, this is the inside wall right here. And that actually might clear, so we might not have to move that. So we may actually be fine there. In which case it is just this problem right here that we're running into. And it's one of those things where my solution may actually just not be appropriate. Let us consider. Okay, so here's another idea. We could, instead of going in, go up. That is another idea. So let's look at that one really quick. So I'm going to Control Z actually to undo all this stuff, because I think going up makes more sense. So actually, yeah, I'll do that one just to get us here. And then I will come back up here, there. This can be, actually, what's, we're 3 millimeters to the top of the box, I think. So yeah, 3 millimeters. And then again, this can be, this honestly can be any length at this point, actually. This can be any length at this point. So I will just make it 3 millimeters and call it a day. So we're going to do that. Finish. Extrude that out. Wrong bodies. I want these bodies down here. Oh, we already have it here? Why don't I see it? Oh, there it is. Okay. So two-sided. Two-sided. This is my positive side right here. That is my positive side right here. 2 objects. Bottom case. Inside of the wall. And distance 2 object outside of that. Join. And now we can come back here to the bottom case. I think I want to go from the top of the case, which we don't have a plane for yet. So top of bottom case. There we go. Project this guy and attempt to project this guy. There we go. Okay. And now we can very simply just extrude. Whoops. I should limit that though. Cut that right there. And now extrude. I take that back. Let me project this inside wall too, just because this inside wall is going to limit the intermediary slide, and therefore we don't need it cut. And that does not go all the way through, so we will fix that. Don't need this line now, so there is that. Distance to object. That. And objects to cut just the bottom case. There we go. So that will keep that like that. It does. There is nothing keeping us. Yeah, we can wrap it around. Okay, that's fine. Actually, how do we wrap it around? So our problem right now. Actually, no, I guess that's not that big of a deal issue. Okay, yeah. So this intermediary slide is bolted to this case, which means that this intermediate slide will not skew left and right, which is what I was just considering. Since it won't skew left and right, we don't have to worry about it coming off the rail here. That's the only thing I was worried about. So now we have a stop so that it doesn't slide all the way off the back. And we're good otherwise. So at this point, I do need to mirror some features over to the other side. So create, mirror that guy across. Okay. This does cut off some of the overhangs that we have for printing, just as a minor bonus. Come back in here, mirror that tab across, create mirror. That tab across. I'm going to click this guy just because I can. Oh, never mind, I take it back. That was a silly mirror because we don't even have a left-hand side yet. That's right. All I have to do is mirror the intermediary slide. Create, mirror, component, intermediary slide across the center. There is that. All right. And now the last thing we need to do is, I mentioned this, we're going to have nuts on the inside here, which need to be able to move through the backside. So let's go ahead and get that done really quick. Bottom case. I'm going to back up just a hair because we can add this to the mirror function we have here. And technically speaking, we could, yeah, actually, no, not actually. So it's going to play with the timeline a little bit, the way we're doing this. Let me readjust my microphone because I've been leaning over this whole entire time trying to talk into my microphone. So I'm sorry if it's making noises right now, but my back is starting to kill me 2 hours in. Trying to speak down into the microphone because I did not have it up high enough. I had it down because I was working on the desk and I was trying to see around the desk, but it's kind of silly when I'm on the monitor. So anyway, all that extra tidbits out of the way. This is the back of the bottom case, or outside of back of bottom case. And now we can just project that guy as a reference. We'll include that guy too just in case I need it. I don't think I do, but we'll see what happens. And now we just need so actually one of these things where, let me double check myself because 5.45 is the actually so here's 5.45 is this measurement here, but I need the maximum to make sure that no matter how the because we're not actually countersinking. I said we might, but how much thickness did I give myself here? I gave myself 3 millimeters. I guess we can sink it in. Okay, I take it back. So before we do this, let me do that then. Let me come back to the intermediary slide and toss that countersunk nut into. Actually, no, I take it back. We don't want to countersink both of them because this this guy right here, these 2 bolts want to slide all the way to the front anyway, which means that they're going to be sliding this whole entire length of the intermediary slide, so they can't be countersunk. So that solves my issue. Back to the maths. So here's my hex nut. This is 5.45, and this whole entire diameter therefore is 6.3. All right, good to know. So we need 6.3 on this edge, 6.3, which is actually less than the slide height. So I'm going to prefer that instead. And the bolt itself is like 2 millimeters. I'm going to give ourselves 4 millimeters just as a safety clearance. So that is how we are going to do this. So there's that. There's that again. That happens to be bigger than our nut. So I'm going to do that. And I just said 4 millimeters. So we can have like 2 millimeters of bolt sticking out the backside too, is the concept there. Actually, I don't like how that's looking, but distance to object. Yeah, I really don't like how that's looking. This was maybe a mistake. Okay. Well, I guess it's not that big of a deal. Again, the intermediary. So I liked having the wall in the way here for the intermediary slide to slide against, but I guess it's not that big of a deal that we're missing it, because again, the intermediary slide should be kept straight and not skew because of this guy. The one thing I will say though is that now this makes me want to stiffen this up a little bit, is my biggest issue. So let's see where we're at here. So I kind of want to come all the way on the inside here and extend this lip out to here and bring it down. Because that's going to be awfully flimsy. Shoot. I guess what I could do is, the alternative is to run a Control Z, run a strip into here directly to the standoff to prevent it from flexing. It's ugly. Huh. We're not really, This is unfortunate. This is very unfortunate. Alright, we are so close to being done and we just hit an issue. That's annoying. I guess what I can do is we can add, because this plate, the top plate, is going to be printed upside anyway, we can reinforce this corner using the top plate is what we can do. Okay, that's how we can solve this. Okay. Let me head forward and grab that guy, adjust, and then we'll hop up to the top plate and use that to reinforce that corner. This corner shouldn't, the top plate is stopping it from flexing upwards, and we should extend the top plate outwards, but on the inside, to keep it from flexing inwards, we're going to put a little strip to stop it from flexing. Also, for some reason that looks like that's interfering. I thought I saw some of the overlapping texture right here, but it may just be my screen. Okay, let's hop back up to the top case, and we are almost done, which is awesome. So I'm going to just extend this out to here now, because we made it a little bit extra wide, and then bottom of middle case. Okay, that still works good. So I'm going to go ahead and project out this guy right here as my reference point, and the bottom of the case as well to get a better reference. So there's that. And let's turn the switches off for half a second. And we're going to just run a strip in here. Like I said, I want to keep somewhat away from this guy right here. So I'm going to call this 2 millimeters. And what we got is what we got, frankly. So if this is only 1 millimeter right here, like I said, it's okay. It's 1.5. So I was hoping it was close to 2. It's relatively close to 2. So, and actually, what am I looking at here? Okay, that's a slide. I was going to say, why do I have a cutout right here? That's just a slide. Okay. So distance, body, that guy. There it is. Distance to object. I'm trying to think of how I'm going to actually get to there. It's a little difficult to select. I guess it's right there. Right there? Okay. That looks right to me. So actually, let me turn my section analysis on. That makes sense. Fine. You gonna be like that? Back up. Okay. And let's see how that looks. Yep, that looks right. Cool. All right. So that will stop it from flexing inwards, and the slide itself right here, the intermediary slide, will stop that little lip, free-floating lip, from flexing downwards. And there is no reason I could think of that it should flex outwards. Yeah, I can't think of anything that would put pressure on it to flex it outwards. So we should be fine in that direction. So let's come back up top and look at our whole entire monstrosity as it is at the moment. I can turn the origin off at this point, and so we've got these open sides right here, which is, I mean, it is what it is at this point. I don't particularly like it, but I'm I'm not sure what I do to fix it is my only issue. What we can do is we can create another plate for when these guys aren't sliding, when the slide isn't installed, to press fit into there, because it really shouldn't be so, you know, you just put it in and then maybe put a little stop on the floor here to stop it from getting pushed all the way in. And that's an idea. Let's go ahead and make that really quick, just as one final button up to make sure everything is done on the design side before we move on to electronics in the next stream. So slide cover is what we'll do. I'm going to turn everything off that we would not have, so that would be those two guys. I will go ahead and take the outside of the left side, project it out, and project out that guy. And then all we got to do is just draw a box and extrude it out, and then we'll make a, like I said, a little divot in the case to what did I select here? That's what I'm trying to select. Okay, new body, and I guess also extrude out the back here. So let us open that sketch back up. Do I have that projection there? It doesn't look like I do, so I'm going to go ahead and project that out now. Whoops. Control Z. Come back into the sketch, project that piece out right there. And then what I wanted to do was extrude that out as well, because again, we're trying to keep this covered up. So distance to object there. I think that was right. The selection looked a little funny. And then we can hop back up to the base. The bottom case, obviously. That's what base stands for. And just in the front corner here. Or actually, that probably needs to be extruded all the way out. So let me go back and fix that extrusion then. That Okay, that's going to be two-sided because my outside of bottom case is actually, is that my positive side? That is my positive side. To object is actually inside of the rails is what that is right now. It's not truly the outside of the bottom case. And then this right here, is this still reasonable? Okay, that is still reasonable. Good. Back to what we were doing here. We do not have a bottom. Oh, we do have a bottom. It's up here. Bottom of that guy. There we go. So we'll just grab this corner. Grab, not this sketch. Turn that sketch off. No, that's our sketch that we want. So it's the other sketch we want to turn off. There it is. So we got the bottom there, and then we want wherever this guy ends, which is right here. Yeah, I'll take that. And I just want to make sure I'm overlaying that by a certain amount, some amount. So I'm gonna draw a box in the corner here and then measure this to be like 2 millimeters, because all it is, it's not supposed to get any pressure on it, so it doesn't need to be that big, is the point being. And then distance to object just to the bottom of the slide here. Actually, okay, so back to those bolts. I don't really want to interfere with the bolts, but I do need to cover up this guy right here, which was the plan. Reinforce, I should say, this guy right here, which was the plan. So how do we go about this? Maybe it would have made more sense to... we want to do both, though. Alright. Back to, we have some clearance on the bolts, so I'm going to assume that this isn't going to interfere right here. And then... Actually, let's back way up. And instead of going there, I'm going to go on the inside of the front face. This is that we're talking about, right? Yeah. Inside of front of bottom case. There we go. And I'm going to instead do the top and the bottom at the same time. And extrude them out in this direction so that I can do it at the same time. And I will go ahead and drop this all the way down just because we already have that there. So again, this is just going to be 1 millimeter here. And this guy actually can be, you know, up here in line with this because the bolt isn't going to run into it one way or another. So we go ahead and extrude this out. And again, it only has to be to that object plus a little bit to make sure it hits. Trying to get the front face here. There we go. And then again, it's just got to be there. -1, join. There we go. And that will stop that from getting pushed in. So on the back side, it has this tab which stops it from being pushed in. And on the front side, it has these little bump offs. And hopefully those little bump offs do not interfere with the slide action at all. So let us, I'm not entirely sure, but I think these technically could have gone ahead of this guy. It doesn't want to let me do it right now, so we'll just mirror those across here. It'd be nice to have fewer things in the history bar, but I did not consider this, and this is actually supposed to be features. There's that and that. Okay. And now we can come up here and mirror the slide cover across to give us a more complete view of it. Again, this is going to have to switch back components now. There we go. And we can go ahead and turn everything back on and see where we're at. So without these two guys, this is how the steam box looks now. I can print this obviously in the singular color so that we don't notice it, and I'll even go ahead and do that now. So that hopefully will be less likely, and I might even not even put the offsets in there. Yeah, I think I won't. What is... It looks like I did not... Okay, that's just the bonus slide. Gotcha. The mirror slide. So I am going to come back here before I create these slide covers and throw my offsets in here for the slide itself. How do I want to do this? Just because we have so little meat around here, you know, I'm tempted to put it on the slide itself instead. But the slide itself is also pretty frail, so I guess I'll just live with it. Okay. So we need that and that to give this slide clearance. Minus 0.1, let's say. And again, I'm doing this before I do the slide cover, because the slide cover wants to be whatever this is. And this is new. Minus 0.1. So the slide cover I still want to fit in there, which means that I wanted to take into account those offsets. And beyond that, come up here to, I'm going to turn the slide covers off now. And intermediate slide on now. So this slide, as you can see, has some clearance on there. I probably want to offset the inside of the walls here too, to make sure they don't bind. We have plenty of clearance on the top here, so I won't do the top wall. And beyond that, I believe that is everything. So let's go ahead and just as a final touch, we will do some as-built joints. That guy to that guy, and that's a slider along that rail. Not previewing it, which is interesting. Did I not click it? I did not click it. Okay. And as-built joint. That guy, that guy. Again, this rail. And we will motion link those two. That guy and that guy. I could have done this slightly differently, but we'll be alright. So we then need that guy and that guy. And that is along that guy. Tempt that again. There we go. And we actually don't need the opposite side here because that's already in line. So I can motion link these guys. That does not look correct. Well, let's accept it and see what happens when we actually apply. Yep, that is not correct. There's that. So that is functioning correctly. Let us... This, technically speaking, should be like half distance. So let's see if that makes difference. It kind of does. Motion link. Whoops. Motion link. There we go. -5. Go the opposite direction. Yeah, alright. I was just doing it for fun. I'm not going to spend too much more time trying to get that right. Right now, we can always figure it out later. So, yep, that was a 2.5 hour stream. I will go ahead and get this printed out so that we can see it in real life. And on the next stream, after it's printed out, we will go ahead and do the electronics. I'll go over the electronics, how that all is getting set up. One thing we did not do is the box for the Arduino. I am actually okay with that because that is just going to be a very, very simple box, and therefore I don't see the need in designing that on stream. I'll go over it with you guys on stream next time. but frankly, it's going to be a square box with a couple holes in it is all it's going to be. And these bolts right here, we're going to do the same exact thing. These bolts will go all the way through, same exact thing as this slide is what I mean. So the bolts will go all the way through, 2 capture nuts in the top of the Arduino's box is how we'll attach this guy to that guy, and the Arduino's box, or actually no, I take it back. The Arduino's box won't have the slide covers. The second set of switches stacked above this guy on this guy will have the slide covers. So that's what you can expect to see when you get back here. Again, I don't think it's really necessary to do that on stream because it's so simple. I'm just going to draw a box and then put some holes in it for JST connectors and the USB cord. So one of those things. I think you guys will forgive me for not bothering wasting your time with something so simple and trivial. It has no moving parts, so I can't imagine it possibly going wrong. Which is, excellent foreshadowing, so look forward to that one. But regardless, as always, thank you guys for watching. I hope you enjoyed this. Look forward to this project, the next portion of this. Also, the CNC machine, obviously. One of those things, I'm really up on getting that one done. I was going to do it this afternoon instead of this project, but I figured it would make more sense. Well, A, I've got so many projects running right now at the same time that I figured the stream needed some variety, which is why I did this one instead of that one. And B, I figured it made more sense to wait till my palm wheels came in, the V-rollers came in, since those should be arriving. That way I can actually have part of it assembled, because it's all printing, it's just waiting for parts coming in the mail. So I figured that one can wait till the parts come in, since we have all the other stuff on the agenda. Otherwise, the stream deck we're doing right now, the CNC machine I just mentioned, again, as always, looking around, arcade stick. I'm not entirely sure what I'm doing with the arcade stick next. I know I mentioned that I've been lazy with the mouse type palm joystick attachment to it, and I still have been lazy, so that has not had anything going on with it. The animation program, there we go. So actually at this point in time, honestly, the palm wheel should be showing up at any point, so I don't know whether to promise you later on tonight the CNC machine or the stream animation. The stream animation program, again, is something I keep on saying we'll get back to, and we definitely will. It's just hasn't happened yet. And then the epoxy resin project, conductive epoxy resin project, I did not mention in the last stream. That one I want to wait till after the CNC machine is done to do, just because again, part of the reason for doing the mini CNC machine was to measure resistances across to get a resistance map across the resin, conductive resin, instead of doing it by hand manually. Obviously, as I've always said before, as I've said many times before, the point of being a DIYer is to spend 3 times as much time doing something that you could do manually, doing it by creating a new tool or jig. So I'm sticking true to that one, spending an extra 20 hours building a mini CNC machine to measure resistances across an conductive epoxy sheet, instead of just spending 45 minutes an hour taking measurements and double taking measurements. Again, it's fun having in this hobby. Let's see. Other projects. I have mentioned that the magnetic encoder, I have a few different things to do with that guy, back to the analog input to the JavaScript, etc. So that will happen at some point. And yeah, I don't know if there. I'm blanking on any other projects that I have mentioned in the past that we'll get back to at the moment. I have started to keep a list since I mentioned that I should be doing that. I just don't feel like pulling the list up because it's on my phone. Actually, there's one more thing that I could mention. I did pick up some games on the Steam Summer Sale. I'm trying them out right now. Well, I'm supposed to be trying them out right now. I actually have been streaming instead. But once I figure out what games seem like they'll be fun to stream, I will be streaming some more video games on the channel in the near future. So, anyway, with all that being said, my 10-minute outro, signature 10-minute outro. Thank you guys all for watching, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're in the world, and I will catch you next time. As soon as I find the end stream button. See, this is why I need a stream deck. See ya.